Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Exclusive Lines by Narrator. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Digits separated by a black dot are in a 1 to 2 ratio. Digits separated by a white dot are consecutive. Not all dots are given. So as an example, say we had a black, imagine this X being a black dot. Say this was a black dot here, and this was a 2. This would have to be 1 or 4 to maintain the 1 to 2 ratio between them, because there was to be a black dot there. And say this was a 6. If that were a 6, this would have to be 5 or 7, because these digits must be consecutive, because there's a white dot between them. And that's an example of how these crop key dots work. We have dynamic fog of war, where deducing the digit in the highest visible checkpoint, marked with the green square and a number, will reveal new cells and potentially a new checkpoint. So if we place the correct digit in this cell, and it's the highest visible checkpoint, so this is checkpoint number 1 because it has a 1 in the square. I assume that once we find another 2, another green square with a 2 in, that would be the next checkpoint. So if we place a correct digit in the checkpoints, they will clear some new cells and potentially a new checkpoint. Each line follows a specific constraint type from the list of constraints. It is up to the solver to determine which line belongs to which type. Okay. Each constraint type may contain no repeated digits anywhere in the puzzle. So this is the exclusive part of the exclusive lines. So each line constraint type, again, you can't have repeats of those digits on that constraint type anywhere in the puzzle. At the start of the puzzle, all lines are region sum lines. And box borders divide the lines into equal sums. So this is a region sum line, this is a region sum line, which means these 2 digits add up to what that digit is, and these 3 digits add up to what that digit is, because the box borders divide the lines into segments, and they must sum up to the same sum. So since that's the case, these 3 must sum up to the same sum as this digit, which is obviously just that digit itself. And that's how region sum lines work. We have dynamic lines. When a new checkpoint is revealed, remove the determined line types and all enter digits except those on checkpoints. So once we clear out this checkpoint, when a new checkpoint is revealed, so all these digits stay the same until we see a new checkpoint, which is a green square with a number in it. And when we see that new checkpoint, we have to, these lines no longer are the same, are necessarily following the rule that we had. And we need to remove all digits except for the digits in checkpoints. And we are allowed to use the new line constraints. So what happens when we get new checkpoints? Checkpoint 1, so once we clear deducing the digit in the highest visible, okay. When a new checkpoint is revealed, remove and enter all. So checkpoint 1, Additionally, the lines can now be German whisper lines, where adjacent digits differ by at least 5. Or as I like to call them, whisper 5 lines. But is that after we've completed checkpoint 1? This is a little confusing, actually, in the rules. I'm assuming that it's only when we place a digit in the new checkpoint that these lines can now be German whisper lines. Because if it's German whisper lines from the start, I'm pretty sure there's no way we can solve this. So if this were, say, could be German whisper lines, then if we had a 3 here, this would have to be 8 or 9, because those are the only digits which are 5 or more away from 3. And I like to call them, I like to call them whisper 5 lines, which a setter came up with the name, and I thought it made a lot of sense because it's very easily extensible. So I think this is after we see checkpoint 2, would be my guess. Where we see a new checkpoint. When we clear out all the potential meanings for lines, and also we remove all digits, right? Except for the checkpoint digits. So I assume that's after we've filled in at least checkpoint 1 and seen probably checkpoint 2 as a cell. So I'm assuming after checkpoint 2, after we see checkpoint 3, additionally, the lines can now be parity line, which are digits alternate between odd and even digits. So, for example, if this were an odd digit, this would have to be even on these lines, if that were the case. You have completed the puzzle when all 3 checkpoints are revealed and the complete grid is filled. Okay. I hope I made that clear about how the rules work. So again, I think it starts off that these are region sum lines. And once you reveal the second checkpoint, I assume you basically no longer know what these lines are. The lines could still be region sum lines, or they could be whisper 5 lines after revealing checkpoint 2. And we remove all the digits except for the digit in checkpoint 1. And then once we see checkpoint 3, that would mean we remove all the digits in the grid except for checkpoint 1 and checkpoint 2. And then the lines could also be parity lines along with whisper 5 and region sum lines. And then when we have all 3 checkpoints are revealed and the complete grid is filled, we have completed the puzzle. So I hope that made sense. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So here is 3 digits adding up to this digit. So this is 6, 7, 8, or 9. Which means this must be 5 through 9 here, because these 3 digits add up to a single digit here. 6, 7, 8, 9 is consecutive with 5, 6, 7, 8, 9. This must be 3 through 9 here, which means this is 2 through 9. It can't be 9 here. It's 2 through 6 here. So this cannot actually be... So the region sum line, these 2 digits add up to this. These 3 digits must add up to that. This can only be 2 through 6 here. These are 1 through 6. So this can't actually ever be 8 or 9. So these digits must be less than 7. And it can be 1 through 6 here. And we can't have repeat digits on the constraint types. Okay, so these cannot have repeats, and these 4 cannot have repeats. Interesting. Okay. Uh, so can this ever be 6? I think the answer to that is no. If this is 6, this is 1, 2, 3. We can't have 1, 2, 3, or 6 here. So this is 4, 5 at minimum. Which would require this to be 9, but it would have to be consecutive with 2 or 3, which is impossible. So this can't be 6. What about 7? 1, 2, 4 here with 7 would mean one of these is 2 or 4. We would have to have, what? 3 and 5 here at minimum, if that's the case. And that adds up to 8, which is not consecutive with this digit. So 7 doesn't work. What about 8? 1, 2, 5 doesn't work because these two digits don't add up, would add up 1, 2, 5. So realistically, these have to be 5 digits at least, which are distinct, which add up to 2 digits. So that's at least 15, which means this can't be 3, 4, or 5. It has to be 6 or 7. If this is 6 or 7, that's only consecutive with 4, 5, or 6. This must have 2 unique digits adding up to from 1 through 3, because to add up to any single digit with 3 unique digits, you're guaranteed at least 2 of them have to be from 1, 2, or 3. Right? Because to add up to 6 is 1, 2, and 3, which is 3 digits from 1 through 3. To add up to 7 is 1, 2, 4, which requires 2 digits adding up to 2 digits from 1 through 3 to add up to that. To add up to 8, it's either 1, 2, 5 or 1, 3, 5, which also require 2 digits from 1 through 3. And to add up to 9, it's 1, 2, 6, 1, 3, 5, or 2, 3, 4, which add up to, which have 2 digits from 1 through 3. So one of these digits must be 1 through 3 here. So this is 8 or 9, which means this cannot be 8 or 9. We don't have any constraints about these Kropke dots, though, because they are not lines. Can we ever have 8 here? If this is 8, this is 1, 2, 5, or 1, 3, 4. 1, 2, 5. The problem is the minimum there would be 3, 4 here, which would make that 6. Sorry, 7, which is not consecutive with 5. If we try to have oh, this can't be 4. This is 5 or 6 here. So it cannot be 8, because if this is 8, this has to be 1, 2. Which means this must be a 9. We've tried all the 8s. So this one of these has to be 6. We tried, again, these add up to 15 at least for 5 unique digits, which have to be unique because they are the same line type. And since they are the same line type, there are no duplicates. Or no repeats. And we tried 8 with 1, 2, and 5. That doesn't work because that's 3, 4, adding up to 7, and 7 and 5 aren't consecutive. So this cannot be 5, which means this is 9, which is only consecutive with 8. There we have checkpoint 2, so we have to delete these digits anyway, so we don't care. Is there any specific combinations there? 1, 3, 5, 2, 4, 6. That works. Or 1, 2, 6, 3, 4, 7 also works. So we don't care about those, though, because we have to delete all the digits anyways from the checkpoints. So now we have Whisper 5 lines potentially in the region sums. Interesting. We have 4 digits here. We have 5 digits here. Region sum. So again, there are no repeats. on these lines of the line types. So because of that, what do we know? These digits have to be 2 through 8. Region sum can never have a or whisper 5 can never have a 5 on it, because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not digits. And then we also still have region sum lines. So the question is, which of these can be region sum lines and which of these can be whisper 5 lines? Well, 8 is consecutive with only 7 or 9. So this is 7 or 9. And therefore is a high digit. 8 is also a high digit. This cannot be a whisper 5 line. If this is whisper 5 line, you alternate between high and low digits on a whisper 5 line. So these would have to be obviously different sets. These would be different sets, so these are the same set, and these would then have to be different sets. But again, 1 through 4 is not consecutive with the digits 6 through 9. So there's no way that this can be a region sum, or this cannot be a whisper 5 line. So this must be a region sum line here, guaranteed. Since this is a region sum line, we have another region sum line somewhere else. But the problem with... So the region sum lines must sum up to the same sum. And if you have a region sum line which uses all 9 digits, that's going to sum up to an odd number, which is the digits 1 through 9. Right? 1 through 9 add up to 45, but that's going to have a sum. In the region sum lines, you're always going to add up to 2 times a sum if you have the line in 2 regions, which all of them are. So that means the region sum line cannot contain all 9 digits, which means that eliminates this from being a region sum line and this from being a region sum line. So those must be whisper 5 lines, which means this is the other region sum line. This is high, which makes this low, which makes this high, which makes that low. This becomes a low-high pair. And this is low, so that means this must be low or 5. And this is a region sum line. Since this is low or 5, these are guaranteed to be lows here. This is a low and a high on the region sum line. Sorry, on the whisper 5 line. And this must be a high-low pair on the whisper 5 line also. So we have a guaranteed low and high here. We have guaranteed 2 lows here. Which means of this set... Well, actually, we have 2 lows and a low or 5 here. That means these digits, 3 of them, at least one of them is high. So since these are high, sorry, one of these is high because we have low and low or 5 here on the region sum line, and they cannot appear here, we are guaranteed at least one of the, at least one of these must be a high digit. And since we know this is high, one of these two is high because you alternate between low and high digits on a whisper 5 line, and one of these is high, that means this can never be high. So this is low or 5. These cannot be more than 2. Can't be more than 1 high digit here, because one of these is high, and we have both of these high digits here. So this must be 1 high and 2 lows or 5 here. So we have 1 high. That means this is low or 5. And because these are 5 lows or 5s on region sum lines, this has to be... you could have a high here or here. These have to both be high then, because we have all the digits 1 through 5 accounted for in the low and high digits. This has to be 7, 8, or 9. This is 1 through 4 here, 1 through 5 there. Therefore, this is 1 through 4 here, 1 through 4 here. This has to be 1 through 5, which is consecutive with 1 through 6, which is consecutive with 1, 2, 3, 4, 6, or 7. So this is a high. So it's 6, 7, or 9 here. This is a high. So what digit do we have to be missing from the region sum lines? It has to be an odd digit. Because if we're missing an even digit from the 8 digits on the 8 unique digits on these region sum lines, the problem is the sum will sum up to an odd sum when there's supposed to be 2 times a sum for both of the lines. So since we have all the blues accounted for, we must be missing a 7 or a 9. So we have to have the 8 somewhere on this region sum line. So this must be an 8. And we have to have 6 somewhere on this region sum line. So 6 could be here. But 6 could also be... oh, we can't have 6 anywhere in the middle portions of this Whisper 5 line. Because if we did... where is 6 on this Whisper 5 line? Because we can't have 5 on the Whisper 5 line, and that's the only digit missing on the Whisper 5 line. So we have to have 4 available, and we have to have 6 available. Well, 6 can't be either of these, because if this is 6, that would require 1 and 1 to be on the Whisper 5 line, which is not allowed. Same with this. If this is 6, that would require 1 and 1, and we'd have a repeat on the Whisper 5 line, which is not allowed. So 6 has to be one of these two, which means this can't be 6, it's 7 or 9. That means the remaining digit on this region sum line must include a 6. And these digits are consecutive by 1. So 6 has to be one of these 3. If we had 6 here, that's already 6 and 8 on this side. The problem is this would have to be a 5 or lower. And 9 plus whatever 5 or lower is not going to add up to 6. Or it's not going to add up to 6 plus 8. Plus another digit. So, this can't be 6 here, which means 6 has to be here. So that's 6. This is not medium or 5. This must be consecutive with 6, which is a 5. So we have 5 and 8. This cannot be 6 and 7. This must be 6 and 9, which makes this a 2. So we have 5 and 2 here, no high. 9 eliminates 9 here, so that's 7, which means this can't be 7. We have to have 1, 3, and 4. This is obviously not low. This is not 5. These can't be 5. It's not 2 or 5 here, which means this cannot be 6 here. This cannot be 7 here. So 2, 5, 8 add up to 6, 9, and therefore that leaves 1, 3 adding up to 4 here. So this is 4, and this is 1, 3 as a pair. This is consecutive with 4, so it must be 3 only. This is 3 next to 8 or 9. No 7 anymore on the high digits. 8 cannot be in any of these cells here because of the 8s in the row. So where is 8 on the whisper 5 lines, which it has to be? It has to be here. So this is 8, which leaves this as 1 or 2. So we need to have a 6 and a 4 available on these whisper 5 lines now. So this must be a 4-6 pair, which must be different from 1 and 9, or must be next to 1 and 9 on the whisper 5 line. So this is 2, because 4 can only be next to 9 on a whisper 5 line, and 6 can only be next to 1 on a whisper 5 line. So this is 4 or 6 here. We have a 1-9 pair, which eliminates 1 and 9 in the rest of row 7. So this is 3-4 as a pair, which eliminates 3-4 in the rest of the box. Well, 3 and 4 is only consecutive with 2 and 5 here. And the only digit here that can be is 5. So this is 5, which is consecutive with 4 or 6. But the 3-4 pair eliminates 3 and 4 in the rest of the box. So this can't be 4. This is 6, which is consecutive with 1 on a whisper... Sorry, next to 1 on a whisper 5 line, which makes this 9 and that 4. So when we have 6, 5, and 4 there. So now we have checkpoint 3. So we need to delete everything except for the digits from the checkpoints. And yeah, oh, I didn't know we could delete that. That's pretty cool. We have to delete the line segments. So we know this is a 4, and we know this is an 8. So again, this is consecutive only with 7 or 9. So that's low. This is 3 or 5, and this must be then 2 or 6 here. So this is low or 5. We have four more digits here. Okay. So we have a new line constraint, which is parity lines. Oh boy, okay. These digits are consecutive. So they cannot be 8, cannot contain 8 or 4. So we have 1, 2, possibly. This is 1, 2, 2, 3. No 4. It could be 5, 6, 6, 7, and that's it. No, nothing with 8s. So this is 1, 2, 2, 3, 5, 6, or 6, 7. Can this be a parity line? We've already proven this can't be a whisper 5 line. So can it be a parity line? And I think the answer is no, right? Odd. If this were odd, this would be even, this would be odd, and this... No, that actually does work. It could be a parity line here. Okay. Maybe that's not where we attack then. These digits must be in a 1 to 2 ratio, and it cannot have a 4, so it's either 1, 2, or it's 3, 6. Can this be a reason sum line? The answer is no. Because this digit cannot be the sum of 4 unique digits. It could be a whisper 5 line. Can it be a parity line? These are consecutive, so if this were odd, that would be even. Say this was a parity line. If this were odd, that would be even, and that would be odd, which is not going to be consecutive. So this must be a whisper 5 line here. And since every digit is unique for these digits, the other whisper 5 line in this puzzle has to be these three, because we cannot have two unique digits. Sorry, you cannot have two repeats, a repeated digit on all the whisper 5 lines. And since these are combinations of 5 and 4 and 3, we have 5 digits here, which leaves only 3 digits remaining on the whisper, possible to be on a whisper 5 line, and we can't have all of them be. There would be too many. These would be combinations of 8 and 9 digits uniquely on those lines, and 3 more added to it would basically make sure we have a repeat, which is not allowed. So therefore, this must be a whisper 5 line here. Now we have region sum lines and parity lines. So this could be a region sum line here, or a parity line. This could be a parity line also. So could this. But we know these are the region sum lines. So we have to have 6 in this whisper 5 line has to be one on the ends, because it cannot be next to 2 unique digits on the whisper. It has to be at the end, because it would, if it were in the middle, it would be next to guaranteed a 1 and a 1. So 6 has to be one of these 2 digits here for the whisper 5 line to work, because then you'd have, if you didn't, you have to have all the digits 1 through 4 and 6 through 9 on a whisper 5 line somewhere. And 4 can't be here, because 4, again, can only be next to 9 on a whisper 5 line, so it has to be at one of the ends. And 4 can't be here because of 4 in the column, so 4 has to be one of these 2, which is next to 9 in the middle, which would have to be next to another low. So 6 could not be on the end here, so 6 has to be on the end here. And it must be next to 1 on the whisper 5 line, which eliminates 1 as a possibility in the rest of the column. So this is now 3 and 6, which means this has to be 6, that's 3. That forces this to be 1, which is consecutive with 2. And we have 4 in one of these 2 cells, and it must be next to a 9. So this is 7, 8 as a pair here. We have to have 3 and 4 remaining on the whisper 5 lines. This can't be 3 because of 3 in the row, so that's 4, which makes that 3. This is consecutive then with 3, which is 2 or 4. Now, okay, so this is even, so this could be a parity line. It could also still be a region sum line here. We are not certain. So the region sum lines is either going to be all 5 of these 5 digits and another set somewhere of 4 digits. Oh, these have to be 5 and 4. Because you can't have 5 and 5 having 9 unique digits on those lines. Or, yeah, 9, no repeats on that line, essentially. So you have to have 5 and 4 together for the unique digits for both the parity line and the region sum line. Well, if this were the 5 for the region sum line, the problem is the same problem that we had earlier when we tried to make this a region sum line with a 4. It doesn't work because they must add up to 45, which as a region sum line, if they go only through 2 regions, it must be 2 times the sum. Therefore, this cannot be the region sum line. It has to be the parity line. So this is parity line here, and this must be region sum line here. Well, this must be greater than, it must at least be 2, and it can't be 2 and 4. It must be 2 and 5 adding up to this digit, which is 7 or more for that digit. Well, we have a 7, 8 pair in that box for that, so this must be then 9. We have 9 here. That means this must be either 2, 7 or 4, 5 adding up to 9. And this can't be 3, 6, so it could be 1, 8, 2, 7, or 4, 5, adding up to this 9 here. This is a parity line. If this were a region sum line, it would be 7, 1, 2, 4, but that would eliminate all possibilities for this pair adding up to the 9 here. So this cannot be the region sum line here, so this is also the parity line here, which means this is the region sum line here. This is a parity line. We don't know which one's which. So this is odd, these are odd, and this must be even. So we have 2, 4, 6, 8 here. That means we have 2 odds and 2 evens here. We must have 3 odds and 2 evens here, which means the 3 odds are on the ends and in the middle, and the 2 evens are between them. So this must be even. This must be odd. No, this is then 2 or 6. This is odd. 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. And this is 2, 4, 6, 8. Cannot be 8 because of 8 in the box. So so this is 2 or 6, which is consecutive with 1, 3, 5, or 7, so that works. Where is 8 on the parity lines? It has to be there because we have all 9 digits because there are no repeats on the line. So this must be 8 there. That means this can't be 8. This is 7, which makes this 8 there. This digit's consecutive with 2, 4, 5, or 7. So that leaves us 1, 3, 5 for 2 and 4, and then 4, 6, 8 for 5 or 7. This can't be 6 because of 6 in the row. Okay. This is odd, so it's 1, 3, 5, 7, 9. These are region sum lines, so these add up to 27. 45 minus 27 is 18, and 18 divided by 2 is 9. So this must either be 2, 7, and one of these has to be 3 or 6. So this could be 3 or 6 also. And then this could be many things. 1, 8, 2, 7, 3, 6, or 4, 5. No 8 here, so no 1 there. No 4 here, so no 5 there. Okay. Where is 4? Well, 4 could be here or here. 6 is one of these two on this parity line. That means this cannot be 6 here because it sees both of these cells, which means this can't be 3. This can't be 3 because of 3 in the box. Okay. We are guaranteed one of these is 3 or 6. Because we don't have a 3, 6 available on the rest of the region sum lines. So either this is 3 and that's 6, or this is 3 and that's 6. So these 3's both see this cell, so this can't be 3. This 3 sees both of these cells, or sees all of these cells, and this is consecutive only with 8. Remaining digits in row 4. cannot have 1, 2, 3, 4, or 9, so it's 5, 6, 7, 8. Which means this can't be 7 or 8, it's 5 or 6 there. Remaining digits of this 8 eliminates 8 from being here, so this can't be 8, that can't be 1. Oh, this 3 eliminates 3 here. So that forces that specifically. So this is 5. This is not low or high. This is 5, which makes this 6 and 3. So we have 6 and 3 there. This can no longer be 6. Where is 6 on the parity line? It has to be here. So this is 6, which is only consecutive with 5 or 7 on the parity line. No 6 here, no 3 here. 6 eliminates 6 here, so this is 5, which means this can't be 4 or 5. It's 2 or 7. No 5 or 7 here. This can't be 2 or 7, it's 4, which means the last even digit on the parity line is 2. So this cannot be 2. This can't be 2, 7 as a pair here because of the 2, 7 already on the region sum line. So no 2, 7 here. This can't be 5, so therefore this can't be 4. This digit's consecutive with 2 or 7. 2 is consecutive only with 1 or 3. 7 would be consecutive with 8 here. Okay. This sees both 1, 8 and 4, 5 guaranteed. So this cannot be 1, 5 or 4, 8. So it must be 3 here. And this is consecutive with 3. It must be 2, which makes this 7. These have to stay the same because the restrictions, the lines are basically still the same, right? We don't have an additional line where we can have additional digits be on, and these repeats are still the same. So this is 3, and now we just have to do, well, we have to figure out the no restrictions, right? So this can't be 7 because of 7 in the column. Where is 3 on the parity lines? Can't be here, can't be here, it must be here. So this is 3. Remaining digits of box 6. These can't be 3 because of 3 in the column. So this has to be 3 here. Remaining digits then in box 6 are 4 and 6. Okay. What else do we have? These are consecutive. These are consecutive. So this has to be consecutive. And you cannot have 4, 6, or 3, or 9. So it could be 1, 2 as a pair. No 3, no 4, no 6. So that eliminates 4, 5, 3, 4, 4, 5, 5, 6, 6, 7. You could have 7, 8 here as a possibility. Either way, whichever one this is, it's either 1 and 2 consecutive or 7, 8 consecutive. And that requires 1 and 8 guaranteed to be here. Sorry, that guarantees that 1 and 8 cannot be there because we are using 1 out of either 1, 2 or 7, 8. So therefore, this must be 5 and 4. But since this is 5 and 4, this must be 1 and 8 here because we already are using the 4, 5 on region sum lines. So this can't be 1. We have a 5, 7, 9 triplet on parity lines. So this can't be 5, 7, or 9. Therefore, this is 1. These are consecutive. These are consecutive. So this cannot be 1, 2, or 3. So what are the possibilities here? We have 4, 5, 6, 7, 9. 4 is consecutive with 5 because we can't have 3 here. 5 is consecutive with 4, 6. 6 consecutive with 5 because 7 can't be here. 7 can be with 6 or 8, and 9 can be with 8. These digits cannot contain 3 or 4, so we have 1, 2, 5, 6, 7, 6, 7, 7, 8, and 8, 9. But this can't... Oh, this 6 eliminates 6 here. So that's 8, which makes that 6. So no 6 or 8 here. which means if this is 1 or 2, it could be 1 or 2 here. If it's 5, 7, or 9 here, this must be with 6 or 8. So no 5, 7, or 9 there. Remaining digits in column 6 are 4, 5, 6, 7, 9. No 4 here because of 4 in the row. This can't be 7 because of 7 in the box. And this can't be 6 because of 6 in the box. That leaves this digit as a 2 here in row 9 because of the 5, 7, 9 triplet. Remaining digits in column 9 are 8 and 9. So this is 8 and 9. Oops. This is 8 or 9, and this is 8 or 9. Remaining digits in column 8 are 1, 7, and 9. Where is the 2 in column 7, then? Can't be here because of 2's in the boxes. Can't be filled in digits, so it has to be here, which means this is a 1-2 pair, which eliminates 1, 2 in the rest of the box. This can't be 1 here. It's 7, 9 as a pair, which eliminates 7, 9 in the rest of the column. So this is 1, and the 7, 9 pair eliminates 7, 9 in the rest of the box. So this is 8, which makes this 9. Therefore, this cannot be 9 here. This can't be 1 and 2, because that would eliminate all possibilities for this cell here. Also, these have to be 7 and 8 remaining in column 7, and this 8 eliminates 8 here, so that's 7 and 8 there. This can't be 1, 2 as a pair for this consecutive digits, because they would eliminate all possibilities for this cell. So this must be 5, 6, 6, 7, 7, 8, or 8, 8, 9. This can't be 8 or 9 because of the 8 in the row. But it could be 4, 5, 5, 6, 6, 7, and some of those possibilities. Remaining digits in box 4. We have 2, 5, 7, 9. 2 cannot be here or here because of 2 in the row and 2 in the column, so 2 has to be here. And then the remaining digits are 5, not 5, 7. This can't be 5, this is 2. So this is 2, this becomes 5, 7, 9. And 9 can't be here because of 9 in the column. 7 can't be here because of 7 in the row. We have a 5, 7, 9 triplet in column 3, which eliminates 5, 7, 9 in the rest of the column. That leaves us with 1, 3, 4, and 8. This can't be 4 in all these digits here because of 4 in the box. This can't be 3, no 8 there because of 3 and 8's in the row. So this is a 1, 8 pair, which eliminates 1 and 8 in the rest of the column. This can't be 1, it's 3. This can't be 1, 3, or 8, it's 4, which eliminates 4 here. 9 is one of these two digits here. Remaining digits of box 1, we have a 1, 8 pair here, so this is 2, 5, 6, 7. So no 5 or 6 here because of 5 or 6 in the row. This can't be 2 because of 2 in the column. Where in column 2 is a 1, can't be these two cells anymore, so it can't be here because of 1 in the row, so 1 has to be here. Remaining digits of row 8 are 4 and 9. This can't be 4 because of 4 in the column, so this is 9, which makes that 4 here. 9 eliminates 9 here, so it's 7 and 5. 5 eliminates 5 here, so it's 9. 5 eliminates 5 here, so it's 9, which means this cannot be 9 here. So 9 eliminates 9 from being there. 5, 7 as a pair, eliminate 5 and 7 in the rest of the row. Remaining digits in box 7 have to be 3 and 6. This can't be 3 because of 3 in the column, so this is 6, which makes that 3. 7 eliminates 7 in the rest of the column, so this can't be 7, that's 2. There's no 2 or 7 here. It's 5 or 6. No 5 or 6 here because of 5 or 6 pair in the column. Or sorry, in the box. So this is 7, which makes this 5, which makes that 7. This can no longer be 5 and 6 as a pair here because that would eliminate all possibilities for this cell here. So this cannot be 5. We have a 7, 9 pair in row 2 now, which eliminates 7, 9 in the rest of the row. So this can't be 7 or 9. It's 5 or 6 here. And now we have a 5-6 pair in row 2, which eliminates 5-6 in the rest of the row. So this can't be 6, it's 8. This can't be 8, it's 1, which makes that 8. 1 eliminates 1 here, so it's 2 and 1 there. 7 eliminates possibility of this being 7. So for this to be consecutive, we can no longer have this be 5 and 6 because that would eliminate all possibilities for that cell there. So this must be 4 and 5, which eliminates 4 and 5 in the rest of the row and box. This can't be 5, it's 6, which makes this 5 here, which makes this 6. 6 eliminates 6 in the rest of the column. We now have a 4-5 pair in column 6, which eliminates 4-5 in the rest of the column. So this can't be 4, it's 9. This can't be 5, it's 7. Remaining digits in row 9 are 2 and 5. So this 4 eliminates 4 here. So this is 5, which makes that 4, which makes this 5. That 5 eliminates 5 here, so that's 2 and 5 there. We don't know where the 1s are necessarily. 2s, we have 8 2s, so we know where the last 2 has to be. It has to be there. 7 eliminates 7 here, so it's 9 and 7, which eliminates 7 there, so that's 9. 3s, we have 8 3s. We know where the last 3 has to be. It has to be there. 4s, we don't have enough information. 5s, we have all the 5s. 6s. In column 5, where is the 6? Can't be here because of 6 in the box, and the rest is filled out, so 6 has to be here, which makes this 4 and 6. That should give us all the 6s. 7s, we have 8 7s. We know where the last 7 is. 8s, we have all the 8s. 9s, we should have all the 9s, too. And that leaves 1, which again has to be here, and then that gives us here, and then therefore this is a 4. And that's a solve. Not too bad. It's pretty restrictive. But it was still interesting how we could remove digits and line possibilities, and how it's sort of how adding new lines, because of the exclusiveness of the exclusivity on each line type, that was affected in every time we got a new checkpoint. So that was interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.